Hey everybody, this is Mr. Bells. I'm going to start some of the videos for Geometry A right now. We're going to deal with Chapter 3, Section 1. If you're in the watching this in the 2020 21 year of COVID right now, stay with it as best you can. I know that I only have half of you in class. I will put the homework on Big Ideas as we go through this too. Pay attention to it, take good notes on it. Remember that I'm going to ask you to show me those notes as we go through this stuff. So here we go. 3-1. And we're going to start off with some vocabulary right now. So I know this says in your own words, write the meaning of it, but I'm going to kind of go through this so that you have all the definitions as we go. So parallel lines are two lines that are in the same plane that never intersect. So we're going to put stuff just like this. To be able to show that, and what we simply do is we put an extra arrowhead in the middle of the lines to show that those two are parallel. I can also show that two lines are parallel with two long little sticks like that, two vertical lines. This is saying that A is parallel to B. Okay, so skew lines. Skew lines are ones that are non-coplanar. Non-coplanar. So like if I had a box just like this, and try and show you some depth in this case. So skew lines don't intersect either, just like parallel lines don't intersect. But skew lines don't intersect and are non-coplanar. So like this line right here, so if I extended that up, you can see that that one would go just like that. And then this one right here happened to be skew. So I know that you can see that this would come down and you think that it would touch this one, but it's in a different plane. So again, that's what makes it skew. So parallel planes, like your ceiling and your floor in your room, those are parallel planes. Left side wall, right side wall, those are parallel planes. And you know, there's an infinite number of parallel planes in between too, so it doesn't have to be a physical structure. There could be imaginary slices all the way throughout. In fact, if I put the textbook kind of like this, and you can see this, we're talking about hundreds and hundreds of parallel planes right there in your notebook. Okay. So what the heck is a transversal? So let's say I got two lines that go just like this. Whether they're parallel or not parallel, I don't really care. But if I take them and I slice them with another line just like this, that is considered a transversal. Okay, and we're going to get to a point where we talk about if those angles that are formed in here are congruent or supplementary or not, based on the transversal and if those lines are parallel. But if we're just talking about names right now, these are some of the names. So what I'm going to do right now is I'm going to give you two lines just like this. I'm going to give you a big, we'll call this angle A, angle B, angle C, angle D, angle E, angle F, angle G, and angle H. And if you guys put your letters in there, make sure your letters are in the same place as my letters. Okay, so now we're going to talk about what all of these things are. So the first thing I'm going to do is I'm going to talk about corresponding angles. So there are several pairs of angles that are corresponding angles. So I'm going to put this A and E are corresponding angles because they're both above the lines and to the left side of the transversal. So this is like upper left quadrant of this and upper left quadrant of this. So they correspond to the same location. So then B and F are also corresponding angles. And let's go C and G. C and G are both corresponding angles because they're both lower left side, and then of course H and D are corresponding angles. Okay, and you really have to be good at knowing what all four of these things are as we go through here, because they're going to have some relationships later again if the lines are parallel or if they're not parallel. So alternate interior angles. So interior angles would be angles that are formed in between these two lines. And then alternating means they go from one side of the line to the other side of the line from top to bottom. So C and F are considered alternate interior. They alternate top, right, and the inside, right, just the inside ones. C, D, E, and F are the inside ones. So alternating from top to bottom and left to right. Okay, and then the other ones are D and E. Okay, alternate exterior angles. So exterior angles are like AB and GH. They're on the exterior or the outside of these two lines. And then alternating means, again, from top to bottom and left to right. So A and H and B and G. Good deal. And then consecutive interior angles. Consecutive interior angles are the ones that are on the inside. So C, D, E, and F are all interior angles, but consecutive ones are on the same side of the line. So C and E and D and F. Okay, so those are the names. Now, we could also have consecutive exterior angles if we wanted to. That would be A and G and B and H, consecutive exterior angles. And that's pretty much what we have. We know already, you guys know, right? If I wanted to do VAT, vertical angles, right? Vertical angles theorem says that these angles are congruent. So we know that I'm going to go ahead and just circle them here for the vertical angles, right? So G and F are vertical angles, E and H are vertical angles, C and B are vertical angles, and A and D are vertical angles. And of course, those are congruent. Okay. The next thing you'd want to know, right? What about linear pairs? Linear pairs. Awesome. So there's lots of linear pairs here. Just kind of make some connections here. So G and H form a linear pair. H and F form a linear pair. F and E form a linear pair. E and G form a linear pair. C and D form a linear pair. B and D form a linear pair. A and B form a linear pair. And A and C form a linear pair. And those also tell us bits of information. Okay? So those are our general things for names of stuff. And again, you got to know them. You got to be good at them. Okay, so what happens over here when we start talking about parallel lines, parallel planes, skew lines, stuff like that? Well, we have a couple things down here, and you can read this stuff on your own. It's not a big thing. It's kind of some of the stuff I already talked about. But right here, this says parallel postulate. Basically, it's saying this. There's exactly one line through P that's parallel to L. So if I have a line, and I have a point that's not on the line, and on another video, I'll do a construction for this one here. It basically says that there is one and one only line that goes through that point that will then be parallel to the given line. Okay, there's only one, exactly one. Okay, there's an infinite number that are skew, like if we started doing them at different angles coming in, right, through that point. But if they're in a plane, there's only one line that's parallel to it. On the next page, you'll see this too, but I'm going to draw it right here. There's also one and only one line that goes through that point that is perpendicular to the given line. Okay, so exactly one line parallel to it and exactly one line perpendicular to it that goes through this random point that's not on it. And this one's called the parallel postulate. We're going to assume that's true, and this one's called the perpendicular postulate. And all of these angles over here, these are the ones that we just talked about and what the names are, and you can put the other ones down from it. Good deal. We're moving through a little bit faster here. So we're going to talk now about some of these things, and hopefully this goes really well. It says in exercises 1-4, think of each segment in the diagram as part of a line. Which lines or planes contain point B and appear to fit the description? Okay, so line or lines skew to FG. So I need to find FG. That one's right there. So any line that is not parallel to FG and doesn't intersect with FG. Okay, so I don't want to necessarily do all of them for you, but I'm going to talk about some things. Obviously, GH, they intersect, and BG, they intersect, so we don't want those. AF, intersects and EF intersects. So we don't want those, because again, skew means that they never intersect. Skew also means that they're not parallel. So you can see that EH down here and FG are parallel. And you can see that FG and AB are parallel. You can see that FG and DC are parallel. Even if it's at a weird angle through the box like that, we can still get that. Okay? So what is skew to FG? So we need something that will not intersect with FG and is not parallel to FG. So how about this one? What do you guys think about that? BC? BC is going to be going up and down here. Now, you would think, right, that it would kind of touch like right there. But remember, there's depth perspective. FG is way back here. BC is out in the front. Those two things will never touch. And AD, same way. It's skew to that one. Good deal. HC, skew to that one. ED, skew to that one. Okay, now even though it's not drawn in the picture, I want to make sure that you're clear on this, that FG right here, right? CE is also skewed to it, even though I didn't draw it in. So don't think that lines can exist or segments can exist just because they're not in the picture. Anytime that you're connecting 2 points, even something like BH right here, you could write that down. Not that I'm asking you to do all of them, I just hope that you know. Okay, so lines perpendicular to FG. So the only thing that we know is perpendicular are things that show those right angles, or things that we can prove are right angles from other stuff. So GB and FA, so GB and FA, hopefully that makes sense. Lines parallel to FG, we kind of already called that, right? AB and DC and EH are all parallel to it. Planes parallel to FGH. FGH, that's that back thing, right? That's kind of like this. When we say FGH, we're really talking about this trapezoid looking thing back here, right? So if we want something that's parallel to it, that would be ABC. So plane. And with this, as long as you're taking any 3 of those 4 letters out of A, B, C, D, it still makes the same thing. So I'm going to go ahead and call it BCD. It could have been DCB or DAB or DAC. Any of those 3, we just got to make sure that they're non-collinear. So plane BCD would be an example of something that's parallel to it. I can't use any other planes here because they would all intersect. So down here on this one, it says name a pair of parallel lines. Well, remember parallel lines have those extra arrowheads on it, so right here. And whether or not you want to call this line UN or line NV or line UV, it doesn't matter. This one right here is line QR, so those 2 lines are parallel. Also right here, these 2 lines are parallel. They have the extra arrowheads right here. It says name a pair of perpendicular lines. Well, there's only one right angle right there that we can go with. So UN or UV or whatever you want to call this, or NV, like I said, and ST or SN or NT, whatever you want to call this one. We just use 2 letters again for lines. We can say that. Now this says is WX parallel to QR. Is WX, right, this one right here, WX parallel to QR? Well, that's pretty obvious. That would be a no. They intersect in that point, and parallel lines can't intersect. So again, this is a no. I'm not going to write everything down, but I'm hoping you're following through on this stuff. Is ST perpendicular to NV? So ST right here, perpendicular to NV. And I'm going to look right here. I'm going to go, hey, what about this angle? What do we know about that angle? Is that a right angle? And the answer is yes, it has to be a right angle. Because this right here is a right angle. And these 2 angles are vertical angles because they're formed by intersecting lines directly across from each other. So yes, that would be reason justification for it. Okay? So here we go. Identify all pairs of corresponding angles of the given type. So this is a little funkier right now because I have 3 lines going through here. But I want you to think about it as you've got this set of 2 lines with this being a transversal. You have this set of 8 angles, where these are your 2 lines. And this is your transversal. And then you got the third one. I'll do some like dashes going around here, where you've got that set and those being a transversal. So when we're talking about all the corresponding angles, we're talking really about 3 different sets of things. So actually, let me make this one squiggly, so you can see that I've got a squiggle one, I got a dashed one, and I got a solid traced one. So remember that with corresponding angles on just this set right here, right, with those 8 angles, we know that there are 4 sets of pairs. So for number 9, not only are we going to have those 4 pairs, but we're going to have 4 pairs there, and we're going to have 4 pairs there. So there's really 12 pairs of corresponding angles. And I'll give you just a quick little rundown for like this one right here. 4 and 8. 4 and 8. Those are corresponding angles. Again, I cover this up, and you can see that 4 is in the top right of this grouping of 4 angles, and 8 is in the top right of this grouping of 4 angles. So they correspond to the same location. Okay? Number 10, remember there's 11 more of these ones. Alternate interior angles. Let's do it with the solid line right here. Do it with the solid line. I'll give you both of those. Those should be 3 and 10 and 4 and 9. And you can put the other ones down. 4 and 9. Alternate exterior angles. So let's do it with the dashed ones right here. Alternate exterior angles. So the exterior angles are 9 and 11, right? And 5 and 6. Those are the ones that are on the exterior. So 9 and 6 and 11 and 5. 9 and 6 and 11 and 5. And remember, there's more than what I'm writing down. I'm just trying to get you a decent idea of it. Okay? Consecutive interiors. Let's do that one on the squiggle right here. Consecutive interiors. That one on the squiggle. So 5 and 2 and 4 and 7 would be those ones. Okay, so this is our introduction to skew lines, parallel planes, and all of those different types of angle connections. Hopefully this was really helpful, and really, again, stay on top of all the vocabulary, because our next few sections are going to build onto this further and further and further. We'll talk to you later. Thanks.